All right, guys. So we're looking at 4.4 for the honors and 3.4 for my math 7 students. Okay, this says solve percent change and percent error problems. Okay, so it says how is percent change related to the percent equation? So I wrote the percent equation up here again. Part equals percent multiplied by whole. Now the difference is that we're going to be doing a percent change. In other words, whatever the change is here, we're going to put that equal to the percent change. So this is the amount of change with the percent change based on the original amount. Now you're going to see this works most of the time. But the thing is that when we get to percent error, it's a little bit different. So that's why I'm going to do this a little backwards this time, and we're going to go to the quiz question first before we go to the exam. So, quiz number 5, okay, quiz problem number 5. Okay, so what this is they're saying which one is the greatest year of growth, okay? They say that year 1, they had 14 students, year 2, 19 students, year 3, 25 students, and then year 4, 33 students. I already marked down change, percent change, original. And I calculated the amount of change from one year to the next. In other words, from year 1 to year 2, you would take 19 minus 14, we'd get 5. From year 2 to year 3, 6 more students. From year 3 to year 4, 8 more students. Now, what we're doing here is we're going to go through and we're going to do change. So if we're going year 1 to year 2, right, we're going to calculate that one first. We would do the change, which is 5, and it equals, now the percent change we don't know. So I'm going to change that up here every time we go through and do one of the problems. So I'm going to put that as x, and then we're going to multiply that by the original amount. The original amount here being 14. Now, here's the important part. We want to always isolate the variable. Notice I always use x and y as my variables. So we're going to get x by itself to find out what it's worth. I'm multiplying here. That means I'm going to divide by 14. I'm going to divide by 14. I have to do it on both sides of the equation, or else the equation doesn't stay equal. This is gone. 14 divided by 14 is 1. 1 times x is 1. Then we do 5 divided by 14. And what we find out is that we have a 30. Now, what this would do, it would look like this. X would equal 0.36. Now, what we have to understand is this is a decimal amount, okay? We need to change this into a percent. So we multiply it by 100 or we move it over 2 decimal places. So in other words, in this year here, there is a 36% change. Okay, so a 36% growth from 14 to 19 students. Okay, guys? So now let's look at the next one. We're going to calculate each one of these the same way. So the change from here is 6. Again, we don't know the percent change, so we're going to put x. And then the original amount this time is 19. See how that's the first amount, the original amount, okay? So we're still going to isolate x. So I'm going to divide by 19 since we're multiplying. That means I'm going to divide by 19 over here. This is gone. Okay, then x, if we divide 6 divided by 19, we get 0.32. In other words, 32%. So this ends up being 32%. Okay, so far the change is bigger there's more growth percent-wise from year 1 to year 2 than from year 2 to year 3. Okay, so one more left. Okay, so at this one, it's 8. So 8 is the change. We still don't know the percent change, and we will multiply that by the original, which is 25. We isolate the variable. So I'm going to divide 25 by 25. That equals 1. X times 1 is x. but I have to divide 8 by 25 also, or does not stay equal. X is by itself, and we actually get the same answer as our last problem. We get 0.32, which ends up being 32%. In other words, when you answer quiz number 5, our greatest percentage of growth is from year 1 to year 2. Okay, guys? Now remember, if you don't understand some of this, you need to ask me questions in class. Now, what I wanted to do is actually, I did this backwards for a reason. So we're going to go through and we're going to look at example 3 now. We're kind of going backwards, okay? So example 3. Now, here's the deal. This is kind of interesting because for me, it even got a little bit confusing. Because what they want here is percent error. In other words, how far were they off? Now, in example 3, what they say is a bolt should be 4 7/75 of an inch. But when they made the bolt, it actually ended up being 4 769 thousandths of an inch. So the first thing we did was we went through and we figured out how much was it off. So I took the larger amount, subtracted the amount it should have been, and we get 19 thousandths. Okay. So we put that as our change. Remember, it's change equals percent change multiplied by the original. The difference is that when it's a percent error, they really want the larger number. So P is actually going through and going to be, actually, I'm going to change that. I'm going to change it to X because I said that's what I'm going to use, right? So my percent change is X. That's what we don't know, the percent error. And then we need to put the larger number. When we're doing percent error, we need the larger number, else this doesn't work. And that's what I was saying by it works to a certain extent. Okay. Now, we still solve this the same problem, though, once we get this. We isolate the variable. That means I'm going to divide by 4.769. That means I also have to divide by 4.769 here. So this is gone. X is by itself. When I divide these two, what I get is, and this is kind of interesting, 0. I need to look at this closely. 0.03984. Now it says to round this to the nearest tenth of a percent. See, when I go through and make this a decimal to a percent, I multiply by 100 or I move the decimal over 2 places. We're still only right here. So the tenth of a percent is actually rounding to this place. So I look at this number to determine to round it. That means I'm going to round this one up. So that means that our percent for this is approximate, oopsie, and I didn't even do it right, is approximately 0.4%. That is our percent error on this problem. Okay, guys? So percent error, percent is going to be tough, all right, guys? But ask me questions in class. Make sure you watch this closely. Look at the examples so you understand it, okay, guys? And biggest thing I can tell you right now is to remember and write down these different equations. If you don't have these written down, you're going to have a hard time, okay? Because you're going to want to refer back to them. So our percent equation is part equals percent multiplied by whole. And then this one is change equals percent change multiplied by the original. So you want these equations written down with examples. Okay, guys, if you don't write them down, if you don't understand the examples, ask me in class and I'll explain in more detail. All right.